So we're looking at lowest common multiples and highest common factor. So let's just break this down into the different phrases. There's so many things in maths where we just sort of say the name of the topic. We don't think carefully about what the topic must mean. But this is a good example when we can essentially understand it bit by bit. So look at lowest common multiple. We've got three words there. Let's start with multiple. If I take the number 5, well, a multiple of 5 would be whatever I get if I multiply 5 by anything. And this is, by the way, although it doesn't say so, it's always whole numbers. So obviously I could multiply, for example, 7.5 is a multiple of 5. I'd have to multiply it by 1.5 in that case. But we're not talking about this kind of thing. We're talking about multiplying it by whole numbers. So essentially, anything in the 5 times table is a multiple of 5. So, 5 is a multiple of 5, in fact, because it's 1 times 5. And then any other number in the 5 times table is a multiple of 5. So that's the word multiple understood. Common, what might that mean? Well, basically, if we're looking at another number, like perhaps I'm going to think of a good example here. There's 6 times that. Well, let's say the number 6. So let's look at the multiples of 6. Well, it's 6, and then 12, and then 18, then 24, and then 30. So these are the multiples of 6. What about common then? We just mentioned the word common. Well, notice that they have a common multiple. In other words, a multiple in common. They both have 30. So 30 would be a common multiple of 6 and 5. Lowest, well, it is the lowest, in fact, because it would have more multiples in common. If I went all the way up to 60, then we know that 60 is equal to 6 times 10, so it's a multiple of 6, but also 60 is equal to 5 times 12, so it's a multiple of 5 as well. So 60 is also a common multiple, but it's not the lowest common multiple. The lowest common multiple would be 30. Okay, so this is what we mean by lowest common multiple. What about highest common factor? Well, we now know what common would mean. In all of these questions, we're going to be comparing 2 or more different numbers and looking at their multiples and their factors. We know multiple is a number we get when we multiply our number. So we started with 6 and 5. Now, what we're going to be looking at, and I think I'm just going to take this actually. I won't delete it for now. I'll just shrink it. And I'll put that there, and you can always expand it by dragging the white circles or zooming in. So highest common factor. Well, let's take a larger number, for example, 100 and 70. So what is a factor? Well, I think I might try to use different colours as well. Factor is like the opposite of a multiple. It's not what number do you get by multiplying it, it's what number can it be divided by. So, in other words, 100 can be divided by 5. So 5 would be a factor of 100. It can also be divided by 10, 20, 2. We try to put these in order of if we can, but it doesn't matter too much. It also can be divided by 25. All these are factors. Okay. 70. What can 70 be divided by? Well, it can also obviously be divided by 7 and 10. It can also be divided by 2 and 5. Or 35. Yeah, and maybe some others that I might potentially have missed out. But they're some of the different factors, so numbers that it can be divided by. So this word common now, what does it have in common? Well, 5, they have 5 in common, so that's a common factor. It has 2 in common. It has 10 in common. All right. 100 cannot be divided by 7 or 35, and 70 cannot be divided by 20 or 25, so these are not common factors. Now, of the ones I've looked at here, 10 seems to be the highest common factor. There are ways to determine whether or not I've not missed anything out. And to do that, the general way of doing it would be to use factor trees. So let's demonstrate this with a factor tree of 100 and a factor tree of 70. So if you just follow me over to the right hand side of this board, so we've got essentially all I have to do to make a factor tree is divide it by anything I want. So I could divide this by 2, and then I would get 50. Now, what we do is we keep dividing all the numbers by other things. So, for example, 50 could be divided by 2 again. 2 can't really be divided. I mean, you can divide it by 2 again and get 1 and 2, but that's just going to give you another 2. So we say that's ended. And if it's ended, if we can't divide it any further, then we call this type of number a prime number. So a prime number can only be divided by itself and 1. So 50 can also be divided by 2, which we know is a prime number, so we circle it. And when we divide it by 2, we get 25. So 50 is not a prime number. 25 is also not a prime number because I can divide it by 5. And when I do, I get another 5. 5 times 5 is equal to 25. 5 is a prime number because I can't go any further. So this is a completed factor tree of 100. I didn't need to do 2 and 50 to start off with. I could have done 4 and 25. I would have still ended up with these as the end points. We're doing, and okay, so before I do 70, then let's look a little bit at what can I say about this 100? Basically, what I can say is that 100 is actually, well, I could say it's equal to 2 times 50. I could also say it's equal to 2 times 25, or I could say it's equal to 2 times 5, 2 times 2 times 5 times 5. And that's actually what we're going to do. So this is called writing it. So what I'm doing here is I'm writing it as a product of primes. So I guess we need to know, what does the word product mean? We know what prime is, short for prime number. Product of primes. A product just means what you get when you multiply 2 or more numbers. So we have multiplied these 4 numbers. I haven't got a multiplication symbol there. And therefore, 100 is a product of these 4 numbers. It's a product of these 4 prime numbers. So we're writing it as a product of primes. I'm going to do the same here. In fact, let me pause this and let's see if you can have a go at this one. Okay, good. So this is a completed factor tree of 70. Once we get to a number that can't be divided any further by whole numbers, apart from ignoring 1, and itself, then we draw a circle around them because they would be prime numbers. So 70 is 5 times 2 times 7. Now, usually, in fact, every time I see it, you always write the smallest number first. I don't know if you'd actually get penalised for this if you didn't do that, but I would, just to be on the safe side, try to get into the habit of writing the smallest number first and getting gradually larger. So now what do we do with this then in order to find the the highest common factor and in fact the lowest common multiple, what you do is you do something called a Venn diagram. So you may have seen these before, but basically what a Venn diagram is saying is that, let's say we've got two things like A and B, and then we've got maybe some, in fact I'll just do it with the examples that we're looking at right now. So we're doing 170, aren't we? 170. What we do is we take these numbers 2, 2, 5 and 5 and 2, 5 and 7, and we write them in different places depending on what products, which numbers go into which bits for the prime. So I'm not explaining this very well, but I'll demonstrate it with some examples. So we have, this one's got a 2 and that one's got a 2, so they go there because that would mean it's in both circles. So in the intersecting part, that means it's in the circle that's for 70, and it's also in the circle for the 100, so we put a 2 there. However, the 100 has a second 2, so we have another 2 that's just in this bit, which isn't in the 70 circle. There's a 5 that is in both of them, so we would take this one and put a 5 in the middle. But again, the 100 has got a second 5, so we put that one there. So now the 100s have got the 2 2s and the 2 5s, and the 70 has got the 2 and the 5, but it doesn't have a 7 yet. The 7 is not in the 100, so we have to put it there. So now we've got our completed Venn diagram. To work out the highest common factor, it's the bit in the middle. So the bit in the middle is the highest common factor. So we go 2 times 5, which is 10. So the highest common factor between 170 is 10. Now the lowest common multiple can also be worked out using this. And what we do is we take the numbers and we multiply them all. Okay, not all of these numbers, but all the numbers we've written down in the Venn diagram. So it's going to be 2, and it doesn't really matter too much what order we put this in, because this isn't our final answer. So 2 times 5 times 2 times 5 times 7. This is easier than you'd think, because we've got 2 times 5, which is 10, and then times 2 times 5, which is another 10, times 7. 10 times 10 is 100, times 7. So that means it's 700. So the lowest common multiple for these two is 700. They both can be multiplied to give 700, and that is the lowest number that they have in common. That is a multiple. So that is how to do that. That is how to do. So I'm getting a lot of messages. That is how to do that topic. Now, what I think I would like to experiment with is letting you have a go at these questions on your own. However, you may struggle a little bit with these wordy questions. So I will just demonstrate just one of them on this video. So, in fact, I'm going to stop this video here and I'll demonstrate just one of them on a separate video.